Welcome to Sir Abrar YouTube channel. This channel is now a generalized channel about the electrical engineering, all engineering, IT, information technology, computer science, business, and especially the immigration, Canada, new streams, in latest proposals coming up for the students who are studying there or who intend to go to Canada, especially. And business setup, startups, those topics will be covered for basically Canada and USA because a lot of our new engineers, scientists, computer scientists who have innovative kind of abilities, they have started the startups. So they want to take the business from North America. So they want to set up the company in USA usually. So we will also upload the videos on business aspect, which will cover the filing, registration, how to get a agent there in USA. There is a condition, and then the taxes in USA and Canada, and other laws like anti-spam law. So you will see the videos on all those topics now in this channel. So please subscribe and share with your colleagues, family members who are not engineers, but they may be interested in setting up business there. They may be in IT. They may be interested in getting education or work permit in Canada. So now this particular video is about the electrical power engineering, and today we will discuss that what is the slow front waveform and what is the fast front waveform, and what is the utility, what is the name. So in short videos Q&A, I have touched this topic: insulation coordination. Insulation coordination is what? It is a selection of voltages, abnormal voltages, which are imposed on the power system, and then the power system insulation or the dielectric strength of the equipment, bushings, etc., must be able to withstand that extra voltage, extra old voltage, abnormal frequency. Now, these type of voltages, they can be categorized in two basic areas or the forms. Number one is the switching impulse, and other is the lightning impulse. Now, switching impulse means when you switch on and off a line, transformer, or anything which is inductive, or you switch on off the capacitors to improve the power factor. All these give rise to the switching impulses, and that switching impulse is not of a power frequency. That may be up to 500 hertz, or maybe more than that, 1000 hertz. The other one, the lightning stroke, that is a different kind of waveform, and that waveform has a different frequency. So all these two waveforms, all the equipment must withstand the dielectric strength of the equipment, or the insulation material must withstand the over voltages which are encountered by a power system. Now, impulse impulse surge or impulse voltage or the impulse waveform is known as the slow front waveform. Slow front waveform. Why? Because this waveform or this kind of impulse, switching impulse, rises slowly but not very slowly. You will see that it is still very fast, but as compared to the lightning impulse. So this wave, the switching impulse rises very rapidly, but in 250 microsecond it reaches its peak value, and then it drops to the 50% value in another 1250 or some microseconds. So this is the rise in 250 microsecond, which is very high speed, but it is known as the slow wave front because it is rising in 250 microsecond to the peak value. It is taking 250 microsecond to reach a value of peak value, whatever, from 0 to that value. Now the other waveform, other impulse, which is known as the lightning impulse lightning surge, that is known as the fast front waveform. Fast front waveform, FAST. Just because that the this waveform, which is the lightning stroke or the lightning impulse waveform, it rises to the peak value in just 1.2 microseconds. How much? 1.2 microseconds. So this is known as fast. The other one is known as slow because that switching impulse waveform rises in 250 microsecond. Remember, microsecond, not millisecond. For the question in the interview, please don't forget. But normally, such a technical questions are not asked in the job interview. So I am not covering that in the job interview question. But this is a very important area because all these voltages are selected according to the IEC 60071, and then the all the equipment, it is mandatory that all the equipment must be tested for the switching impulse and the lightning impulse, and also for the power frequency or voltages. So when we cover the testing of the equipment, we may cover in the installation coordination area. In the next video, I will tell you that how to select this value, that how and from where will you find. Suppose you have a 132 kV power system, how to find and where to find that value for which you must select the equipment, because this 132, you know, it is known as 145 kV, 220 is known as 245, that is the maximum operating voltage, rated voltage. So how much should be the basic impulse level or the lightning impulse level, or how much should be the switching impulse level for which the installation or the equipment must be designed to withstand. So how to find that value for which the equipment will be designed, for which you will be procure, the value which you will write that your equipment must be able to withstand this much voltage of switching frequency, switching impulse, and this much voltage in case of the lightning impulse. So that is very, very important. And in the next video, I will discuss with that in detail as well. So you will find these detail in IEC 6071. If you don't have that, just go to the net, search that IEC 60071 or write insulation coordination IEC. You will find these old versions, but these things have not changed. So it doesn't matter which version or which year you find on the net. So you can always find on the net. Thank you very much. Please subscribe our channel. As I told you, this is now a generalized channel for business, IT, and engineering and education. Thank you very much. Please help us to promote our message all across the board to the junior engineers, senior engineers, and across the all the population which is interested in Canadian immigration, studying there, and setting up a business in USA and Canada. Thank you very much.